The question is, prove by mathematical induction, and what do they want us to do? 8 to the n plus 2 lots of 7 to the n minus 1. They want us to prove that it has a factor of 7, or that it's divisible by 7. You guys get that it's the same idea, right? Okay, good. So let's just proceed as we usually do. I should have mentioned the allowable values. Some of them actually start at 0, which is interesting, but this one is normal, so just natural numbers, okay? So our first step, of course, is to test. So what's our first allowable value? It's just 1. So I get 8 to the 1 plus 2 lots of 7 to the 1 minus 1, okay? So that's 8 plus 14 minus 1, so that's 21. So that checks out. Good. So now I make my assumption, which is this for k. So I've got 8 to the k plus 2 lots of 7 to the k minus 1. And I'll let that equal to something. And I should introduce the two numbers that I've just started talking about, okay? And they've got their conditions on them, which we've noticed before. Sometimes that's really important to how you do your proof. Okay, now I'm going to move this over. What do I actually want to prove off the basis of that assumption? The next case over, which is just k plus 1, because you guys have noticed when it's sometimes k plus 2 or k plus 3 or whatever. So this is what I want, k plus 1 plus 2 lots of 7 to the k plus 1 minus 1 equals some other positive integer. All right. Excuse me. All right, now, so far so good. Lots of different approaches that we could use. This isn't an inequality or anything like that. What you see here and what we're required to prove, it looks like I think I can find the assumption somewhere in there if I twist and turn it enough. So I'm going to start with the left-hand side. I'm going to say, well, first, I know I've noticed as people have been writing, they've been a bit like they've skipped lines and they've just started working with it straight away. It's a bad idea. The proof has to be really watertight, okay? So I'm just going to write it out verbatim. So now I've got 8 lots of 8 to the k there. I've got 2 lots of 7 lots of 7 to the k there. So that's just my index laws. Yes? Okay. Now, the reason why I would do that is because the assumption doesn't have k plus 1s in it. It's got 8 to the k, 7 to the k, and I can see those there. The question is, well, how many do I have? So I've got 8 here, and how many of these do I have? I've got 14, don't I? 14 of those minus 1. Okay. Now, the question then becomes, all right, how much of the assumption can I see is present here? How much can I see? Now, I can see, well, yeah, I can have 7 of them. I can take out 7 and I'll have some leftovers, won't I? Okay. So if I say, let's take out those 7, I'm going to have one of them there, and then I'll have 7 times 8 to the k there, which lines up with that term. Then I've got 7 lots of that already, so I'll just leave that be. And then I've got minus 1. Okay. All right. Now, here's the thing though. This assumption has a 1 in it, right? So I need, if I want 7 lots of this, I'll have 7 of these, 14 of these. So far so good. But I'll need negative 7 there, won't I? Okay. So that's minus 7, but I can't just change that to a minus 7, can I?
Add 6.
So I'll add 6. Okay. So now what do I do? What can I actually do? So I can take out a factor of 7 here. Okay. So that'll leave me with 8 to the k plus 2 times 7 to the k minus 1. Okay. Plus what was left over, which is this and this. Okay. I made a mistake. Now, the reason why I could tell, I wonder if you could tell why I made a mistake. I looked at this. Now, you often get to this point in induction proof and you think, okay, I either have, there's something about this that I don't know, okay, or I've done something wrong, right? Now, I was a bit naughty. I should have said by assumption there. Oh, no, it's okay. I haven't actually subbed it in yet. I haven't subbed in my 3p. Wait, 3p? Why did I say 3p? That should be 7, shouldn't it?
Yeah.
Okay, anyway, that's a minor thing. Now, here's the thing though. This is not going to factorize nicely. If this factorizes nicely, like we expect, this should too, but I've got a problem, okay? So instead of this, I'm going to try something else. I've obviously got to reshape this line in some different way that makes that factor of 7 easier to pull out, okay? Now, we tried pulling out 7 lots of the assumption, but that wasn't very useful to us, okay? So what else could we try? Now, you can take out however many number of the assumption you like. Some are more useful than others, right? So for instance, from here, suppose I just took out 1. Suppose I just took out 1. Now, one of the reasons why you might say 1 is because I just have a -1 there, don't I?
Yep.
Okay. So if I just take out 1 of these, what will be left over? Well, I'm going to have 7 lots of 8 to the k and then 1 lot of 8 to the k. That's interesting, right? I'm looking for 7s, aren't I? Then I'm going to pull out 1 of these from here. If I pull out 1 lot of that from here, I'll be left with 12 times 7 to the k. Is that okay? Right? Plus 2 lots of 7 to the k. I don't know why I started writing brackets anyway. There's my 8 to the k is accounted for. There's my 7 to the k is accounted for. -1. Okay, so now I've got, let me use this. I've got this guy, and I've got this guy, and this guy. That's exactly what my assumption is, right? So therefore, I can sub them all out for 7p, can't I? 7p. Now what's left over? I've got 7 times 8 to the k, and I've got 12 times 7 to the k by the assumption. You guys need to write that out in 4. I've just run out of space, okay? Well, that's it. That's it, isn't it? Well, it's almost it. So let me take out a factor, 7, right? And then what's going to be left? Well, I've got p, that's an integer, that's good. I've got 8 to the k, that's an integer, that's good. Now what happens here? I've got 12 times what? Well, because I've taken out a factor of 7, this is going to be 7 times k to the -1. Now that you have to be careful of, right? Because depending on, like, negative indices are a bad idea. This is a divisibility proof, so I want everything to be in whole numbers, don't I? Okay, so I can't just ignore this guy. I can say this is a positive integer, no problems. This is a positive integer, no problems. But this guy, on what grounds can I argue 12 times 7 to the k-1 will be an integer? And I have to appeal back to what I specified k can be. So the very smallest that k can be is 1. The very smallest it can be. So that would make the smallest value that this takes 12 times 7 to the power of 0. So that's 12, isn't it? 12 times 1. So that's good. And of course, as I take subsequent values of k, it just gets bigger from there, and it stays a whole number. Okay, so being that all of these pieces are whole numbers, therefore I can say that's 7q, where q is equal to all of that rubbish inside the brackets, because that's what it looks like. Okay, so there. Now it's true for the next case. Using the assumption, and you can sort of carry it from there and just finish off with your explanation. So it's actually kind of handy that I made an error there, because when you get to a point like this, we just sort of give up, don't we, right? But that tells us, okay, I used the assumption, great, but I didn't use it in a way that was helpful, because there are helpful ways and there are unhelpful ways, okay?